Good afternoon, everyone. This is my next video in PMI where I'm going to discuss Type 2 and Type 3 models. So, questions are chosen from NCERT. Question number 13. I've already told you there are 4 types in PMI. First video covered all questions from Type 1. Do watch the video. I'll share the description. I'll share the link in the description box. So, today I'm going to do Type 2 and Type 3. Type 2 questions are the ones where you see terms in multiplication form. As you can see here, 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9. So everything in multiplication form. Just see the 14th also, that's also similar to it. 1 plus 1 by 1 into 1 plus 1 by 2 into 1 plus 1 by 3. Whereas if you see the previous type where terms were expressed in plus form. So let's start with the 13th question. Every time we consider the given equation as P of n. So 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9, so on, 1 plus 2n plus 1 by n square equals n plus 1 the whole square. Now let us take n as 1. That is the general rule, isn't it? Until otherwise state in the question. So n equal to 1. So when n is 1, p of 1 would be 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9, so on till 1 plus 2 into 1 plus 1, so that is 3 by 1 square, which is 1, equals 1 plus 1, 2 square. So when you take LCM, you get 4 here. 3 by 1 plus 1 is anyway 4, and this side is also 4. So sum of nth term and nth term value is same. So the statement is true. Now let's go for P of k, which means we assume n equal to k. So we get 1 plus 3 by 1 into 1 plus 5 by 4 into 1 plus 7 by 9. So on, the last term is 1 plus 2n plus 1 by n square. Sorry, n is k na, so put k. 2k plus 1 by k square equals k plus 1 the whole square. Assume P of k is true. Assume P of k is true, and this will be the inductive steps for P of k plus 1. So I'll substitute this only to prove k plus 1. So next, n equal to k plus 1. So P of k plus 1 would be 1 plus 3 by 1, 1 plus 5 by 4, 1 plus 7 by 9, so on, 1 plus 2 times k plus 1 plus 1 by k plus 1 the whole square equals to k plus 1 plus 1. So that's k plus 2 the whole square. So this is the statement that we have to form. We have to prove. So I'm going to take the left hand side of this, which is 1 plus 3 by 1 into 1 plus 5 by 4, so on, 1 plus 2k plus 3 by k plus 1 the whole square. Hope this step is clear. 2k plus 2 plus 1, so 2 plus 1 is 3. Alright, now, so if this is the nth term of k plus 1, this is the k plus 1th term. If this is k plus 1th term, the previous term, which is kth term, will be this. Isn't it? So when n is k, the last term is this. When n is k plus 1, the last term is this. So the previous term will be k. So the value of that is this one. So 1 plus 3 by 1 into 1 plus 5 by 4, so on. The previous term is 1 plus 2k plus 1 by k square into 1 plus 2k plus 3 by k plus 1 the whole square. Here term will be in multiplication form. That is the only thing that you need to remember. Now sum of 1 to k term, 1 to k term sum, 1 to k term sum is k plus 1 the whole square. So that gets substituted here, k plus 1 the whole square plus, not plus, into 1 plus 2k plus 3 by k plus 1 the whole square. Now remember, what do we need to achieve? We need to get this. This is the RHS, okay? So we are working to get this now. Right, let's simplify this. K plus 1 the whole square into k plus 1 the whole square plus 2k plus 3 by k plus 1 the whole square. This will get cancelled. So we get k square plus 2k plus 1 plus 2k plus 3. So that is k square plus 4k plus 4, which is nothing but k plus 2 the whole square. Isn't it? So we got the RHS. Correct? So that's it. So this is type 2, where the kth term sum will be added with the k plus 1th term value. Clear? Now let's go to type 3. So type 3 question, 3 power 2n plus 2 minus 8n minus 9 is divisible by 8. We don't have a series here or a sequence, but we simply have an expression and we need to prove that this is divisible by 8. Now the first step is P of n such that it is 3 to the power of 2n plus 2 minus 8n and minus 9. Until otherwise stated, it is all for natural numbers. So we substitute for n equal to 1 and check whether the statement is true for 1. So when I substitute, 1 is 3 power 4 minus 8 minus 9. And if this term is divisible by 8, then the statement is true, isn't it? So 3 power 4 is 81. 81 minus 8 minus 9 equals to 64. And 64 is divisible by 8, isn't it? No doubt about it. So P of 1 is true. Now let's go for K. So P of K would be 3 to the power of 2k plus 2 minus 8k minus 9. And we generally assume P of k is true. True meaning what? It is divisible by 8. So I assume it is 8 times lambda. Well, how? General algorithm. Dividend equals to divisor into quotient plus remainder. Now where is the remainder? Remainder is 0 because it is divisible by 8. I am assuming that it is divisible by 8. So that means the remainder case is 0. Isn't it? So lambda is the quotient here. So I am assuming 3 power 2k plus 2 minus 8k minus 9 is divisible by 8, and number of times it is divisible is lambda times. Alright. So the yellow ones are just for understanding. You don't have to write that. So now I am going to continue going for k plus 1 statement. So P of k plus 1 would be 3 to the power 2 times k plus 1 plus 2 minus 8 times k plus 1 minus 9. So that means we get 3 to the power of 2k plus 2 plus 2 minus 8k minus 8 minus 9. Now since we assumed k is true, we have to prove k plus 1 also true, isn't it? Now listen very carefully. The previous one was like a series. So we were taking the previous term, like if it is k plus 1, the term is the last term, we take the kth term before that. Here we cannot do anything like that. So what I am going to do is, I am going to apply this statement over here. So I'm going to substitute this over here. So every time we'll take k statement and we induct that in k plus 1. Even here we do the same thing. So there, since we know that, I'm going to do this in a different color to help you understand. We know that 3k plus 2 minus 8k minus 9 equal to 8 lambda. So 3 to the power 2k plus 2 is equal to 8 lambda plus 8k plus 9, isn't it? So that one I'm going to substitute here. So you can ask me, where is 3 power 2k plus 2? Here, right here. So 3 to the power of 2k plus 2 into 3 square minus 8k minus 17. Now here, in the place of 3 power 2, I'm going to substitute that. So 8 lambda plus 8k plus 9 into 3 square. 3, the bracket is very important. 8k minus 17. So that is 8 lambda into 3 square plus 8 in 8k into 3 square plus 9 into 9, which is 81, minus 8k minus 17. Now simplify this. Try to take whatever is possible to take out. So 8 lambda into 3 square, 8k into 9 minus 8k plus 81 minus 17. So 8 lambda into 3 square, and here if I take 8k out, 9 minus 1 is 8, plus 81 minus 17 is 64. So is it possible for me to take 8 common out? Of course. 8 out, 9 lambda plus 8k plus 8. And I'm going to assume that this is equal to lambda 2. So I proved this is equal to lambda 2, where lambda 2 equals to 8k plus 9 lambda plus 8. So that is enough to show that this is divisible by 8. When something is divisible by 8 or any number, if I am able to take that number common out, it is assumed that it is divisible by 8, provided no remainder is left off. And there is no remainder here. Therefore, we proved that T of k plus 1 is also true. Clear? And I'm going to do one more sum in this type. So the type 3 question are 20, 21, 23. In that, what I did now is 22. 20 and 23 numbers, so you can handle it. I would like to do the 21st question. X power 2n minus y power 2n divisible by x plus y. So P of n such that it is x power 2n minus y power 2n. Now when it is 1, we need to see whether the statement is true. Well, when I substitute 1, it's x square minus y square. X square minus y square is x plus y into x minus y. So do you think this is divisible by x plus y? Yes. X plus y into x minus y is of course divisible by x plus y because I can cancel it, isn't it? So P of 1 is true. So the given statement is true. Now let us do P of k. P of k will be x to the power of 2k minus y to the power of k. We generally assume P of k as true. So x to the power of 2k minus y to the power of 2k equals x plus y into lambda. Simple fact, dividend equal to divisor into quotient. Remainder 0. Now let's take k plus 1. So P of k plus 1 will be x to the power of 2 times k plus 1 minus y to the power of 2 times k plus 1. Since k is assumed as true, k plus 1 also have to be true. Correct? Now, for that, we have to involve k statement. Chalo. Now, again, the same step. I'm going to take the k statement. Okay? And I'm going to write that as x power 2k can be written as x plus y into lambda plus y power 2k. And this particular term will be inducted here. Where? In the place of x power 2k. So I'm going to write this as x power 2k into x square minus y power 2k into y square. Then in the place of x power 2k, I'm going to substitute this. So here it will be x plus y into lambda plus y power 2k into x square minus y square into y power 2k. Now x square lambda x plus y plus x square y power 2k minus y square y power 2k. Well, what I have to prove? I have to take its x plus y common out. Well, if I take y power 2k out, this will be x square minus y square. Next step, I'm going to split that y power 2k into x plus y into x minus y. That's it. I can take x plus y common out. Remaining is x square into lambda plus y power 2k into x minus y. And there is no remainder. So we assume this as lambda 2 or any other constant. So x plus y into lambda 2. Therefore, p of k plus 1 is also divisible by x plus y. Clear? So this is how we do the type 3 question. Watch this video again. Try the other two sums. Thank you.